Alright, so looking at section 6.2, page 161, we have the natural base concept. We talked about in the warm-ups how if we have this value right here of 1 plus 1 over x to the x, as we let this x get larger and larger, meaning that it's approaching infinity, that's going to tell us what the value is for e. So the value for e is 2.72 approximately. So we've got that. Then we're going to look down here at the graph of the function. So look down at the bottom of page 161, and you can see that it says, if we have a function in that form, y equals ae to the rx. This is called a natural base exponential function. Notice how it says if a is greater than 1, and if r is greater than, if a is greater than 0, and if r is greater than 0, the function is going to be exponential growth. If the a value is greater than 0, but the r value is less than 0, meaning that it's going to be a negative value for r, then we're going to have exponential decay. And this isn't so much different than what we did before. Like if we had 2 to the positive x, it was exponential growth. If we had 2 to the negative x, it was exponential decay. Also, think of it this way. Like before we said y equals 1/2 to the x. Remember how we said that that would be exponential decay? Couldn't I also write this as y equals 2 to the negative x? Do you see how that would be equivalent? So both of these are exponential decay. So the only difference between this concept and what we're doing here is that now we're using e's. We still even have the same basic points that we look at. If we plug in 0, anything to the 0 power is 1, so we have the 0.01. If I raise e to the first, it's just going to be 2.718 because that's the value for e. And then the similar thing happens with exponential decay. Let's turn the page. Right here is an important formula. A equals PE to the RT. This is the formula that we can use to find the amount of money. A is the amount of money we're going to have if we start with a certain amount. And if we raise it, we have E raised to a certain interest rate times T. This interest rate has to be as a decimal too. So we'll do some examples of those in just a minute. But first let's look at the properties of these. This works just the same as it does if we have x's instead of e's. We're multiplying, the base is alike, so what do we do with the exponents? Add them, right? So this is going to be e to the what? E to the third. I also could have thought of this, e to the negative 9 would be 1 over e to the positive 9, and then times e to the 12th. See how if I thought of this as being e multiplied out 12 times, e multiplied out 9 times, I would end up with 3 more on the top than on the bottom. Let's look at number 2. 25 and 35, what do those reduce to? 5 and 7. Where do we have more e's, top or bottom? How many more? So it's going to be that. All right. Next one, we have to follow our order of operations. So everything has to get raised to the 5th first. What's 2 to the 5th? 32. And then if I have a power to another power, what do we do with those? Multiply, so it's going to be to the negative 15x. And then we have to multiply these two. Well, 32 times 2 is going to be 64e. What do we do with the exponents when the bases are alike? Add them, right? So what are we going to get? E to the... Okay, that's good. Let me show you another way to write this. I don't think many people would think of this, but this would actually be 64e over e to the 14x. Can you see why that would be equivalent? See how these were adding them? So e to the positive one would stay on top, but the 14x could go to the bottom and become a positive. So see how if I now applied my rules, bases alike, subtract the exponents, it would end up being e to the 1 minus 14x would be the same thing. Okay, so just recognize that. You can leave it like this for sure, but understand the other answer. For this one, we have the 4th root of 16. What's that? 2. And now we have also e to the 24x to the 1/4 power. It's easier for me to think of it that way. Like the 4th root of 16 was easy to do, but this e to the 24x, e to the 24x to the 1/4 is easier than the 4th root of it. And so therefore, what's it going to be? E to the 6x, right? Oh, sorry, all right, I want you guys to go through, check these out based on what we just talked about. And all of these, A is positive, so that's not going to change anything. So it just has to do with the exponent. You need to figure out whether it's growth or decay. So write growth or decay under each one of them. Caroline, what did you put for 5? Decay, right? Dominic, 6. Yep. Becky, 7. And Abby, 8. Okay. All right, let's just graph a couple of these. Let's graph 5 and 6 only. Let's do actually 5 and 7. Let's graph those two. So if I want to graph this, I can actually just make a little t-chart. I'm going to plug in 0 and 1. So e to the negative 0 is still just 1 times 2 is 2. So that's also my initial value is 0, 2. If I plug in 1, I'm going to have 2e to the negative 1. Now, that's not something that I can really just, know off the top of my head. I might want to get my calculator out. If you notice, there is an E button. I'm trying to do 2, and then I need to find the E button. The E button is located right here next to the number 4. See how it's in yellow in my calculator? So I'm going to have to do second to get to it. So I do second natural log, ln, and now I can do 2e to the negative 1. Now I can evaluate it. That is 0.74. So there's my other point. And then I just connect those. And I know that it should be exponential decay, and it is. All right, let's do the next one. Just plug in 0 for x and then 1 for x. Anything to the 0 power is going to be 1 times 5. To do the next part, I might just want to type this in. So it's going to be 5, and then I need that e again, e to the 0.25. And that gives us 6.4. And then we can just plot the points. And guys, this is all you have to do on your homework too. When they make you plot these, you can just do quick sketches, just like I am. Something like that. Alright, questions? What about our basic rules here for shifting? We should know what e to the x looks like. E to the x is just that graph that goes just like that, e to the x. What's going to happen if I take that graph and it has -4? What happens to the entire graph? Down 4, right? So here would have been my normal graph, but now that 0.01 got shifted down 4 units. So now it's going to be right there. That 0.1e, or 1, 2.7, is now going to get shifted down 4 units. So it's going to be right there. The asymptote was normally y equals 0, but it got shifted down 4 units. So now it's going to be here. And here's the way it's going to look. If you don't understand the shifting, you could have just substituted in your 0 and 1 again. Anything to the 0 power is 1, minus 4 is negative 3. E to the first is 2.7 minus 4. 2.7 minus 4 is 2.7 minus 4 is negative 1.3. So see how I could have just plotted those points? 0, negative 3, and 1, negative 1.3. Same thing. Okay. What kind of a shift will this one be? We're not actually going to graph it, but what would the shift be? If you have x plus 3 up there, do you remember? Charlie? Jake? Do we agree, Baxter? Yep, it is left 3. So this is going to be a vertical stretch of 2 and to the left 3. Let's just go ahead and graph it real quick. Because it's going to the left 3, I'm going to go ahead and start with negative 3. Because I'm going to get an easy value to work with. Negative 3 plus 3 is 0. E to the 0 is 1. Times 2 is 2. I might want to check negative 2. Negative 2 plus 3 is 1. E to the first is going to be 2.7. Times 2 is 5.4. So if you don't understand the shifting, you might want to do it this way instead. And here's what it's going to look like. So see how it's been shifted to the left 3 units? Normally that point was at 0, 1, but now it's over here, shifted to the left 3. What's going to happen to this one? What does this negative do to it? Flips it. What does the plus 5 do to it? Takes it up 5. Let's just graph that on our calculator. See if it looks how you think it would. Negative, not minus, but negative, e to the x, then outside of the parentheses on mine, plus 5. Zoom 6 it now. Here's the way it looks. Does it make sense? Should. Yep. All right. Let's do these last 2 word problems, and that'll be it. It says the population of Evans City is currently 48,500, and it's declining at a rate of 2.5% each year. You can model the population of Evans City by the equation P sub t equals P sub c e to the RT, where P sub c is the current population, P sub t is the population after t years, and R is the decimal rate of decline per year. Predict the population of Evans City after 25 years. Well, here's our formula. I'm just going to rewrite it. This is telling me the population after t years. It's equal to the current population times e to the RT. Do you see how that's really our A equals PERT? It's the same thing really, isn't it? It's the same formula. So if I want to find the population after 25 years, I'm trying to find out what is the population after 25 years. That would look like that. This is the current population. What is the current population? All right, so we plug that in. E, we just keep it. Now it says declining at a rate. If it's declining, it's going to be a negative 0.025. That's going to have to go in for our rate. And then our t is how much time it's going to take, which is 25. And so that's what we're going to type in. Make sure you can type this in correctly. We've got 48,500 e raised to let's see, e raised to the negative 0.025 times 25. And there we go. So we're going to have 25,960 people after 25 years. Okay? Let's look at 13. Your parents will need $25,000 in 10 years to pay for your brother's college tuition. They can invest in an account with an interest rate of 9.8% that compounds continuously. How much should your parents invest today in order to have your brother's full tuition available in 10 years? Well, we're talking about continuous interest. This is our A equals PE to the RT. Can we think of what we would do here? How would we set this up? Baxter, what would we do?
So you're going to have it 25,000 equals, and then P times E 0.098 times 10.
And how did you know to put all that there? Why didn't you put the 25,000 here?
Because that's the result I wanted, is not the principal.
Right. A represents our end amount. So that's what we want to have at the end. We don't know how much we have at the beginning. So that's why that's our variable. So to solve this then, I just have to divide, because to undo multiplication we would divide. So this is e to the, multiply that by 10, go ahead and do that, that's 0.98. So we would just divide both sides by e to the 0.98, and that should give us our number. Let's see what we get, 25,000 divided by e to the 0.98. So we would need to start with $9,382.78. So if those people were to put that in today and get that interest rate, leave it in there for 10 years, not even adding anything more, they would end up with 25% or $25,000 at the end. Okay, questions over anything? All right, so we learned how to graph with the e's. We learned how to use formulas with the e's. Remember that e just has to do with continuous growth or continuous decay, and it's approximately 2.72. Your assignment's on the board.